Welcome back, friends. So, as I promised you that we are going to start from the very small square of ECG paper. So, first you must know there are two coordinates. Okay, everybody know what are the coordinates. You have learned all this in the math or mathematics or all. So, we have vertical coordinate and horizontal coordinate. In the horizontal coordinate, we are going to calculate the intervals like PR interval, QT interval, this heart rate. This is also that is the unit of time in the second or millisecond. Okay, that's hardly matter. So in the horizontal section we will measure the interval or time. Let me show you how with one more slide. We'll come back to that also. Look, if we have to calculate the height of some wave na, or like T wave or so we just wrong slide was open. Suppose we have to calculate some height of some wave. Suppose tall T wave is there or T wave seems to be tall. So we will use a vertical coordinate. I will tell you, just it's for demonstration. I'm coming back to you. And for the intervals, like various intervals, as you can see, there is a PR interval or other interval, QT interval or heart rate. That is dimension of time. So we have to use the horizontal coordinate. So let us come back to this. So we have a big square and we have a small square. Okay, so as you can see that one big square contain almost 25 this 25 square. So we don't have much to do with 25 square. We have to take the this coordinate wise 5 vertical and this 5 horizontal. So one small square, if its value while measuring the interval or time, जब भी हम टाइम को मेजर करते हैं इंटरवल को मेजर करते हैं तो वन स्मॉल स्क्वायर विल बी इक्वल टू 0.04 seconds, as I have mentioned here clearly. Okay, so one small square will be equal to 0.01 second. You have to remember this. Okay, and when we have to calculate the height or the depth of the waves, so one small square will be equal to 1 millimeter. Okay, suppose the wave is 5 small square tall. So just multiply 5 by 1, simple, so it will be 5 millimeter. So it's not a very big thing or rocket science, but you should understand, maybe it's just revision. So let us now understand how to calculate the intervals. Okay, very easy, nothing so much complicated rocket science. Today I am going to give you idea, and during practice session you will become expert in this. So suppose we have to calculate PR interval. First of all, you must know that PR interval start from just beginning of the P wave to the R wave. Okay, P wave to the R wave, not from here. Some people can think that this is PR segment. So this is the, so just zoom, and I think it is visible. Let me enlarge. If you see here, I for your for ease, I have marked 4 small square because there are total 4, 1, 2, 3, 4, 4 small square between the P and R. So what we have to do, we have to simply multiply 4 with 0.04. As I told you, the value of small square in horizontal coordinate in the term of time is 0.04 second. So here just multiply the number of square appearing between beginning of P to R and multiply. So it's very simple, 4 multiplied by 0.04. So it is 0.16 second. Just for remembrance, I tell you normal PR interval is 3 to 5 millimeter square. Just remember this. Later we, as we move on or go to higher level, then we will talk about prolonged or short PR interval. So for this, similarly, you can calculate QT interval from here to here. Okay. So QT interval, I will be telling you during the teaching session, because QT interval variate with the heart rate. So we have to calculate QTC by using Bazet formula that I will teach you later on. But right now, just for remembrance, you can just remember this thing. So it's very easy. I don't think any doubt about this. If somebody has doubt, they can ask. Any doubt till now? Yes? Any doubt? you can type down, okay, because it will consume time. Okay, so now you understand the ECG paper, calibration, this is small square, and what are their values and how to calculate. That you will become master of this after practice session. This is just to give you idea, and I will also provide you the all theory about this. You don't have to be worried about that. We have to remember or write. No need to write down anything right now. Okay, just it is to give you an idea. So remember, similarly, when you have to calculate the height, I have told you that one small square is equal to 1 millimeter. So as we calculate here, very carefully, I have calculated and even marked small square, and they are around 10. So we can say the height of the R wave is 10 multiplied by 1, because one small square is equal to 1 millimeter. So 10 small square will be equal to 10 millimeters. So it's very easy. If you have to calculate the height of the T wave, especially that is important part, or any other wave, you will use simply this formula. Not formula, just a method. Okay. So now most important thing, before even when you hold the ECG first, what should be the first thing you should notice? As during the demo session, you might have mistake, so lot of mistakes. So we start from the very basics. That is the calibration. Calibration and rhythm lead. What is the rhythm lead? You will say rhythm lead is nothing. It is just at the bottom of every ECG. You will find a long lead. Mostly, as a standard criteria, we keep the lead 2 as a rhythm lead or rhythm lead, because when we have to calculate some certain arrhythmias, we need a long lead. Not just 2-3 beats are not enough. Okay? The heart rate could be irregular, and how could you calculate just with the help of 3 or 2 beats? So this is their rhythm lead. So first, while holding, check the rhythm lead, and before that, check the calibration. Can you see here? Is it visible? You can zoom your screen also. Please check. Never miss this. This is 25 millimeter per second. It is the speed of rotating paper of the ECG. Okay, and this is a 10 mm per millivolt. These are the standard calibration of ECG machine. If it is altered, your heart rate, calculated heart rate, will become wrong. No matter how much you are expert, you will calculate waves as the wrong. Tall T wave, the T wave will become tall, and this, if this calibration in speed is altered, then heart rate become bradycardia or tachycardia, or PR could be prolonged. So you have to check this one first. First thing need to check is the calibration. Just make a habit. Always have a rough look at this, and then start with the rhythm lead. Don't touch this lead first. Okay. First, start with this lead. Check the rhythm, and this is how next thing we are going to tell you, that is calculation of heart rate. So heart rate can be only calculated first you know that the whether rhythm is a regular or irregular. Okay, so because the method of calculation in the both are the different, so you must know how to check the rhythm is regular. If the this RR are separated at the equal distance, here you can see, even no need to even measure. There could be slight variation due to sinus arrhythmia. We call it the RSA, and it is most common in the children or athletes, young athletes. But here you will not find any variation. So you will find perfectly these RR distance are equal. So rhythm will be regular. So calculation of method of heart rate will be different in regular rhythm and irregular rhythm. So must check the rhythm. Then you think about calculating the heart rate. Now let us learn how to calculate the heart rate of the patient from the ECG. So again, here what you have to do. First, you have checked that the rhythm is regular, perfectly regular. Okay. Or as you can see here. So rhythm is regular. RR are separated at equal distance. Okay, so this is the rhythm is regular, we are sure. So what we have to do here, we have to calculate number of big square between two R wave. Number of big square, not small square, big square between two RR wave. You can take any RR wave where whichever is convenient for you for calculation. Okay, so here we can see 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Approximately. Sometimes it happen. It will not be always like just the beginning of the R wave. You will get start this big square will appear. Roughly, there could be this wave can appear in between the big in the middle of the big square. So just take a guesstimate. There are number of 4 R wave. 4 big square between 2 R wave. Now we don't have to do anything. We have to divide it by simply by 300. Just remember this. This thing I will be giving you. Don't worry about it. So 300. Now you might be thinking from where this 300 appear. I would like to tell you this appear from the physics derivations. Physics derivations, as we learned in the physics. Now we have derived so many things. So यहाँ पे कुछ नहीं करना. You don't have to do anything. You just have to remember the figure of 300, and you have to just divide it by the number of big square between 2 R wave. आपको यहाँ पे कुछ नहीं करना है. 2 RR wave के बीच में जितने भी big square आते हैं उनको काउंट कर लीजिए. 4 है यहाँ पे. 4 को सीधा 300 से डिवाइड कर दीजिए. 300 याद रखिए. It is a constant term. Okay, so it is very easy. No need to consult. There are other method also, but just this is enough, more than enough. Okay, so now this was about calculation of heart rate in the regular rhythm. Suppose rhythm is irregular. Suppose this is, look at here. Look at here. It is irregular rhythm. Just in one look, you can see here RR wave is at different intervals between RR is different. You can see. Please check. So this is irregular rhythm. So what we have to do in this kind of rhythm, first we have to choose a rhythm lead. Okay, that is long lead. That is the significance of rhythm lead. So what I have done, just calculate 30 big square from anywhere. For यहाँ से भी start कर सकता है, यहाँ से भी कहीं से भी start कर, from anywhere you want. I have, for convenience, I have started calculating number of 30 big square. 1, 2, 3, 4, 5, 6, 6, up to 30. Okay, and I have drawn a line here to here. Now what I am going to do, I will calculate number of R waves appearing between these 30 big squares. जितनी भी ये 30 big square हमने देख लिए, लाइन मार लिए. अब हमने ये देखना है इतने 30 square big square के बीच में कितनी R waves हैं. So let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9. बस हो गया. That's all. You have calculated number of R waves are 9. You have to multiply 9 by 10. This, now you might be thinking, what is this 10? Again, I will tell you, this is also constant derived from the physics equations that I have told you in the regular heart rate, that you have to divide the number of square with the 300. There 300 was the constant figure. Here 10 is a constant figure if the interval is irregular. Okay, the rhythm is irregular. You have to just multiply it by 10. Okay, so here 90 beats per minute, not exactly 90. We can keep it in a range like 10 plus minus 10. We can say 80 to 100 is irregular heart rate, and heart rate is around 80 to 100. Just 80, 10 plus minus 10 हो गया ना. 10 एक पहले रख लिया, एक बाद में रख लिया, तो 90 से एक कम हुआ, 80 हो गया. ठीक है, 100, 80 to 100. So that is okay. Okay, so next thing, let us move toward the axis, cardiac axis. Actually, I will be uploading a video of calculating axis in the degree. Okay, but what happened, that is the genuine method. But for guesstimating, sometimes you are in a hurry and like that. So there is one more method. It will not, you cannot calculate the axis in the degree, but you will get a guess, rough guess, whether the axis is right, there is a right deviation or a left deviation. So what you have to do, just check check lead 1 and 2. Okay, here you can see lead 1 and lead 2. Just look at the peaks. Peaks are leaving. Okay, leaving each other. Okay, just like leaving. Just remember leaving. And L for leaving, and L for. Okay. I will be covering your doubt in the question answer series, Dr. Smriti. Just let me complete this one. Okay. So L for living. So left axis deviation. L. Just remember L, left axis deviation. Or other things. Peaks are reaching. Peaks of lead 1 and 2 are reaching. So R for reaching, R for RAD, right axis deviation. So this is while you are very busy in the ICU emergency. So just you can take idea that there is a left axis deviation or right axis deviation. So I will give you, I have created a video. It's a very long, you need a practice for this. And I will upload it on the website. You can just take a ECG paper, some graph paper, book. You can get a book from bookstore, and you can practice on your own how to calculate the heart rate in the degree. So right now, that is very long topic to discuss. I have already created a video over that. So it's a long video. You can go through that and understand and calculate on yourself. Okay, so this was all about the short session of the basics. Okay,